So we're going to try something a little bit different today, a little bit more dynamic. And what I want you to do is try and think about what I'm going to be drawing. So I've actually got a light board in front of me here. You can't quite see it at the moment, but you will once I start using these. We're going to be doing a sort of a lecture Pictionary, if you will. So essentially, if you're not familiar with Pictionary, I'm going to be drawing hopefully interpretable drawings on this whiteboard, and I want you to try and think about what I'm drawing, as in what literally is it, and then also once we start getting those guesses incorrect, trying to figure out why I might be drawing them, because we're going to start putting together essentially the underlying foundation for mate choice, but also why animals do a lot of behavior from parental care to provisioning and so on and so forth. So I'm going to start drawing in just a moment, but just to let you know that we do have a live studio audience in the room, because obviously you guys are at home or online and are not able to interact directly. So I'm going to actually start drawing, and you're going to hear people doing some guesses, hopefully, and it doesn't matter if it's not the right guess and not right. My drawing, I have to apologize right at the beginning, is not too crash hot, but we'll start very simple. So you ready? So start thinking about what it is that I might be drawing. Try not to be as squeaky as possible. That's it for one of them. No guesses? Anybody?
A planet?
A what?
Planet?
A planet. Could be.
Egg.
So say that again.
Egg.
Egg.
Oh, okay, egg and sperm.
Egg and sperm. That's exactly right. So it's pretty easy, right? So this is, you know, it's not supposed to be rocket science or anything like that. So we have egg and we have sperm. This is a recurrent theme in this particular lecture on mate choice, and we'll get to why in just a moment. So, egg and sperm, keep that in your minds, and we're going to swap over and do something a bit different over on this side. Now, again, studio audience, keep pumping those guesses out. This is going to be a little bit more abstract, so
okay.
bear with me online as well. So here we go. Just to remind you, or just to prep you, it's not this. So I'm not doing the same thing, right? So, okay, so here we go.
Okay.
Yeah?
Sun. Fish.
How about
A bird? A duck?
a bird? Wow, that's, see, maybe I'm being a bit hard on myself. My drawing is actually quite interpretable. Okay, so bird, that's good. Now let's keep on going. What is this bird doing?
Singing.
Singing, that's exactly right. So this bird is singing his heart out. Now let's just keep on going with this particular individual. We'll actually change our color over to something a little bit more spectacular. So what it is that I'm drawing on this bird?
Is that a tail or a...
Could be a tail. It is a tail, but you know, think of it a little bit. I suspect the people online will kind of know what I'm trying to draw. So it's a tail, but what about this tail?
Is it moving?
It's not moving.
Is it on fire?
It's not on fire. Yeah, so this is, okay, so it's a tail. It's something to do with the male bird who is singing. And let's do, perhaps if I do a little bit of extra color on him. So
Flashy.
it's flashy. That's exactly right. So we're getting kind of to what and I apologize because I think the drawing is actually not too crash hot. So it's a male bird who is singing. He's also quite flashy. So he's conspicuously colored. He has ornamentation. Now, if we were to swap over and have a look at, so this is the male, and let's have a look at what the female would typically be out in nature. So you don't need to guess on this. I'll just give you a quick thing just to draw the female of the same species. And we'll give her a wing, obviously, because she's a bird, and maybe a little bit of a tail. So she is looking at our male, singing his heart out with his extravagant plumage, his ornamentation. Now, often in the natural world, we see this sexual dimorphism. And the dimorphism here is a flashy male and a more cryptic, non-flashy female. So, okay, so we've done one scenario, but let's just keep on going. I'll try and squeeze in something down the bottom here. And again, to our studio audience, feel free to keep having some guesses. Sorry for the squeaks.
Horns?
Horns. You know what? When I'm normally doing this, people guess a bat, but it's not a bat. It's horns. Wow. We got some good guesses in the audience. Okay, so we have some horns. Now, what sort of animals have horns in nature? Just random guesses. All sorts of things.
Moose?
Moose, reindeer, all sorts of things. Insects, rhinoceros beetles, narwhals, you know, those awesome marine mammals with a really long spike on the end of the nose. All of those have these kind of horns, antlers, and spines. Now, these are weapons. Now, again, let's see what the female would actually look like from this same species. So let's say these are deer. So our female deer often do have remnant versions of either the ornamentation or the weapons themselves. Okay, so now we have a lot of diversity in nature. You can see a lot of colourful birds. There's a lot of diversity. Males tend to be very flashy, as Katrina said. We have males that also have a lot of weaponry, so in particular horns and antlers and things like that. But it's not just mammals as well. Whereas the females tend not to have that, and if they do, they tend to be more dialed down versions of the same thing. So what I want you to think about now is why you've got this sexual dimorphism occurring here. But in particular, how it relates to this scenario that we've had over here, which we correctly guessed was egg and sperm. Now, let's return to this, and we're going to make a link to this by drawing some things in the middle here. Now, just again, back to our studio audience, two things that you notice, apart from the color, so it's not the color, two things that you notice that are different about the sperm and the egg as I've got them on the screen here. Any guesses?
The egg seems much larger.
The egg seems much larger, exactly right.
The sperm's more complex?
Sperm's more complex. Maybe, but let's focus on that first one about size. So, eggs are big, sperm are small. Now, there's an implication about the physiological cost associated with producing egg and sperm that also relates to the second difference that you've seen on this screen. Now, this is a cartoon version, right? So what is this? So we've got differences in size. Is there anything else that you can pick out that's a key characteristic difference between these sperm and this egg? Any ideas?
Nothing's coming to mind.
Nothing's coming to mind.
No.
Okay, so big egg. 1, 2, 3, sperm. Sperm are smaller, the egg is bigger.
One egg, lots of sperm?
Exactly. So, big egg, small sperm, few eggs, many sperm. So what we have here is, I'll just write this in there, few. Now, I'll also make a point of, we were talking about size specifically, but we'll focus that a little bit more and say cost. So this is expensive. So I'm hoping you can read my handwriting. I'm notorious for terrible handwriting. Okay, so few and expensive. Now, if we go to our sperm, we have a complete opposite scenario. There are many, and they're also small, so they're cheap to produce. So we'll call them cheap. Now, this is the reproductive physiology behind mating behavior, right? You have a scenario where females are producing a costly resource, and that's the egg. Now, in a female's lifetime, and it varies depending on the species, but the number of those eggs that a female can produce during that reproductive lifetime is vastly smaller than the number of sperm that a male can produce of the same species. Now, to put this into context, if you think of human females, there are only several hundred, perhaps. I'm guessing on the particular number that eggs that can actually produce. But I know for certain that the number of sperm, individual sperm that a male man can produce is enough to effectively fertilize all the females on the planet. So we're talking a major dichotomy here. So there's a lot of investment on the females and very cheap for males. Now, I want you to keep that in mind when we start to think about our cartoon population. So we're actually going to link this physiology of reproduction with what we see in nature and the behavior, so singing and fighting, aggressive competition and things like that. How are these two things actually connected? Let's pick a different color. Right, so we don't need to guess here. I'm just going to start explaining the concepts here. So we're going to do a cartoon population. So we're going to use our symbols for males. This is a symbol for males. You guys are all biology students. You should know that by now. And this is the symbol for our females. Now, it's population of 6, so it's not very realistic. So again, it's cartoon. But envision a natural population where the sex ratio is equal. So there's the same number of males as there are the same number of females. Now, when we have a scenario where females are investing a lot more in reproduction, and if we talk about specifically physiological costs, just the egg itself, it's really expensive to produce. So this means that when we get into nature, females are a lot more selective about how they're going to use their reproductive investment, right? Males, on the other hand, have lots of gametes. They can produce thousands and thousands, millions and millions of sperm. So they just want to mate with as many females as possible. The objective of mating behavior and fitness is to mate, reproduce, and have your offspring survive long enough to reproduce themselves. This is essentially the foundation of most of what we see in nature in terms of survival and social behavior. So back to our population. Now, in this scenario, we have our males that are perhaps a little different in terms of some aspect of their phenotype. The phenotype could be behavior, but of course, that'd be morphology. I'm just going to focus on morphology just because it's easier to draw. This is meant to be a tail. So let's just imagine that our population is a population of birds. So this particular male has a really flashy ornamentation. This particular male also has ornamentation, but it's perhaps not as big. We'll give this other male a little bit more elaboration as well because he's got a really nice coloration as well that females find particularly attractive. This guy, perhaps not so much, so not as much. Now this one down the bottom here, this male is also mature, has everything turned down dramatically. So this male is the most flashy in the population, this one not so much, and this one essentially not at all. So what happens is that females need to make decisions about who they're going to mate with. Again, with this cost, this evolutionary cost in the back of their evolutionary minds. So what will happen is what you see in nature is you have situations where this male might actually achieve matings with 2 of the females, and this male might actually have a mating with 1 female, and this guy gets left out entirely. So this guy has reproduced twice. Let's say they produce offspring. This male once, and this one not at all. On this side, all the females have reproduced. They have effectively used their gametes to produce offspring. So all of the fitness outcomes for the females is equivalent, it's equal. For the males, it's heavily skewed. So when females are trying to make decisions about which males to mate with, we'll get into a little bit more detail about this a bit later, what we find is that males have to come up with some sort of strategy to convince those females that I'm the male that you should be mating and reproducing with. And as a consequence of that, we have males evolving these elaborate behaviors. This is in terms of vocal signaling, ornamentation, and all sorts of strategies to try and be the flashiest male in that population to make sure that they are as attractive to females as possible. Now, not all males can maintain a really flashy existence. It is costly for them to develop those ornaments, and it's also costly for them to perform the behaviors such as singing, which is exceptionally energetic. So only the best males can produce that song and that ornament, which provides females with what we call an honest indicator of their quality. The idea being that if the male is particularly flashy, the quality of that male is genetically derived and is going to be inherited by the offspring that is going to be produced by the females. Now, in the context of other systems, we actually have males physically competing with each other. I could have actually changed and not actually had ornamentation on our male population here, but weaponry. And so what would happen is that the males compete directly with each other through combat to get access to females. This is very common in territorial animals. We've talked about territorial lizards, for example, and that's a classic example. So they compete directly with each other for access to the females, and only the best male, because of his quality, can physically outcompete the other males, and the evolution of weaponry and fighting strategies as a consequence of that. So what we find here is a connection between this skew in reproductive investment right at the outset in the gametes, resulting and explaining the evolution of diversity that we see in nature in terms of behavior and how males look, and why males are often different to what they appear in females, this sexual dimorphism. Now, also, we've been talking about behavior in terms of song and ornaments and elaboration and weapons, but there are other aspects that females look into. This affects parental care and affects all sorts of survival outcomes as well. So in essence, we can actually get a very clear idea about why males and females are doing what they're doing if we understand this fundamental concept in terms of reproductive physiology, what this means in terms of mating systems, and the evolution as a consequence of all of this for the diversity that we see out in nature. So that's it for us. We've now completed our board here, and I'd like to thank the studio audience for their wonderful guesses, and thank you guys online as well.